Hello everyone, congratulations on making it this far in the series. I am going to challenge you to get through the rest of it. Are you going to accept that challenge or are you going to let me down? Yeah, you better accept it. What we're going to be doing in this video is we're going to be talking about the numeric data types in more depth and just some cool things you can do with them. Alright, let's get started. So we talked about how to create a primitive int, something like this. So this is known as a primitive because it's not an object. You can also create an object version by doing integer y and setting that equal to something. So this is going to be stored as an integer object. And I mentioned this in previous videos, most of the time you're going to want to use this. There are some rare occasions when you need to use the object version, but the majority of cases you're going to just use the primitive. Once we get into generic lists, this might come up, but until then, we're not going to have to worry about it. But the reason I bring this up is that I want to call out this integer class. This actually is very valuable to us because it's a class just like the class we're making here, and it has members inside of it. Just like in this MySuiteProgram class, we have this static method called main. Well, inside of the integer class, there are some static methods we can use. So for example, we could say integer dot and see all of the members inside of this class. So the first one's up here. These are properties. Properties are just another name for variables that are attached to a class. And one of these important properties is min value and max value. So if you ever need to reference the absolute minimum value of an integer, you can use that min value here. Let's try it out. Just like this. And there you go, there's the minimum value for an integer. We talked in an earlier video how different data types are different sizes. So you can see that here if you do dot and then click size, this is going to return an integer here, which will be printed out. And you can see the size is 32, and that is 32 bits or 4 bytes. So that's pretty cool, and there are also a lot of methods attached to this class. So you can look through these and see which ones might be useful for you. We're not going to get into these quite yet because I want to talk about how the different data types have the same properties. So for example, I can go to double, and then I can put max value right here. Let's see what the max double size is. All right, so we have some exponential notation, pretty huge number basically. With a double though, only a certain number of digits are considered trustworthy. So like up here, it's more trustworthy, and then at some point, you can no longer trust it. A double is a 64-bit number, and typically it has 15 digits of precision. So after you get 15 numbers in, you can't really trust it anymore. There's also something very interesting with the double that you should know about. And this is across all programming languages, it's not just a Java thing. There's going to be a few special values. The first one is going to be infinity. And there's actually two infinities. There's a positive infinity and a negative infinity. So for example, if we wanted to print positive infinity, it just says infinity. So those are two properties you might want to know about. There is also NaN, which stands for not a number. And this is a special value of double that literally just means it's not a number. There are occasions when certain expressions evaluate to something that's not a number. For example, inside of the math class, there is the square root. And we could take the square root of -1. And what we're going to do is we're just going to system out this, like so. And when we run this, we get not a number. The first not a number is the one we're printing right here. And then the second one is doing the square root of -1. Inside a double, there are methods to test for this. So for example, we could say is NaN, and there's also methods for is finite and is infinite, which the is infinite will test for the positive or negative infinity. But we can just show this double is NaN and pass in the math.square root of -1. And then we're just going to output this whole thing. So it's going to get a little complicated here with the parentheses, but we can do it. And we can see that it outputs true. So the way this is set up is pretty interesting, just so you guys can see how things get evaluated. This math.square root gets evaluated first, and then that, whatever the result is, the return value of that gets passed to this double.isNaN, which is right here. And then the answer of that is passed to the print line. So math.square root -1 gives us not a number. Not a number is passed into is not a number, and it's evaluated to true. And then true is passed into the print line. Just like certain expressions can give us NaN or not a number, there's certain expressions that can give us infinity. So for example, I could do math.pow, and I could take, some really large number here, like 99999, raise that to the tons of power. And then we're just going to, got an issue here. Let me just bring that down a little bit. There we go. It just has to be in the range of an integer. And now I want to output this to the console, and it prints out infinity. You could do the same thing by passing in a negative sign, and then we get negative infinity. So that is your introduction to the numeric data types and just some of the special values that come with the double data type. Hopefully that makes things super crystal clear, and the cool thing here is that the whole concept of infinity, negative infinity, and not a number is not just a Java thing. You're going to get this in JavaScript and other programming languages as well. That's because the double data type is based on a standard IEEE 754 or 754. So if you want to learn more about the double data type, you can check that out.